All right, let me just move this out the way. Lasso select. All right, and I want to move this down. Okay, and then let me just shrink this a tiny bit. Okay, so let's try solving this here, okay? So as we read our problem, we see we take a random sample of 200 people. What is 200? 200 is equal to n, or n is 200. What is 132? This is a count, okay? So I'm going to just say x is equal to 132. And that means p hat, my sample proportion, is going to be x over n, or 132 divided by 200. And if I do 132 divided by 200, I get 0.66. Okay? If you don't believe me, I'll do that right here. 132 divided by 200, 0.66. Okay? So my p hat is 0.66. Okay? So I'm going to put that up here. All right. It says make a 95% confidence interval. So that means I'm going to use 1.96 for my z star. Okay? So I have z star equal to 1.96. Okay? And lastly, I just need n is equal to 200. Is that okay with everybody? Okay, so all I'm going to do is I'm going to just take these numbers and put them into my confidence interval formula here. Okay, let me just get rid of this thing that says margin of error. Okay, so p hat is 0.66 plus or minus z star, which is 1.96, times the square root of 0.66 times 1 minus 0.66 divided by 200. So far, so good? Everyone's good? Okay. All of you who are waiting me to just do it, you guys are okay? You guys are the ones I am rooting for and also most worried about. You guys, I really do want you all to succeed, but it takes both of us to work. Okay, so I'm going to do this, figure out this standard error here. Okay, 0.66 times 1 minus 0.66. Okay, so I'm going to do 0.66 times parentheses 1 minus 0.66 divided by 200. Okay, can everyone see that that's what I'm entering there? Okay, so this is what I have on the inside of the square root. Okay, but I want to take the square root of that, so I'm going to hit square root answer. Okay, and so now I get 0.033496. Okay, so now I have 1.96 times 0.033496 or something like that. Okay. Now, instead of having to retype all that, I'm just going to say times 1.96, okay? Multiplication, the order doesn't matter, so I can say take the answer and multiply that by 1.96, and I get 0.06565, okay? So I'm just going to round that to 0.066. Is that okay? 0.066. So I have 0.66, so oddly enough, 0.066, okay? That's a coincidence that doesn't normally happen that way. I'm not in league with the beast here, okay. All right, so we have 0.66 plus or minus 0.066, okay? So plus or minus, I'm going to do 0.66 plus 0.066, and I get 0.726. So on the high end, when I do the plus, I get 0.726. So that's 0.66 plus 0.066, okay? And on the low end, so if I do the minus, I do 0.66 minus 0.066. And I hit enter and I get 0.594. Okay? So I would say my confidence interval is from 0.594 to 0.726. Okay? Calculation of the confidence interval. Is that okay with everybody? We have a question.
Do you always want us to just keep the decimal place?
You know, I should probably say keep 4 decimal places, okay? In my example, I just did 3, but probably 4 is actually better, but it's fine. Okay, but that's I'm not so worried about. Okay, yes.
What does the confidence interval exactly tell us?
Yeah. Okay, that's very good. That's important, right? So I said don't lose sight of the big picture. Okay, and so we got the calculation of the confidence interval. We just followed these steps here. Okay, but the application, the interpretation, this is the important part. Okay, and so let's go back to our definition. Okay, it says we don't know P, but we take a sample, and from the sample we observe P hat, and P hat's not exactly the same as P, but we expect P to be fairly close to P hat. Okay, so oops, so what do we have here? Our P hat is 66%. Okay, what were we asking for? We're saying we're taking a random sample of 200 Instagram users, and of your sample, 132 are women. Make a 95% confidence interval for the proportion of all Instagram users who are women. So what is the P that we're going for? Yeah, we want to know what percentage of Instagram users are women. Okay, that's the P that we want to know. Okay, and so our confidence interval says, okay, well, we don't know P, but we see P hat is 0.66, okay? And so we're expecting P to be close to 0.66, okay? And what we see is that we go through the math and we found our confidence interval is from 0.594 to 0.726. So what we would say is, I am 95% confident that P, and again, what is P? The proportion of Instagram users who are women let me, I'm running out of space here. Proportion of Instagram users who are women is between 0.594 and 0.726. Okay? Yes?
Why would you always use 99%?
Okay, we'll talk about that in a moment. Okay? Okay. So this statement here says, I am 95% confident that P, the proportion of Instagram users who are women, is between 0.594 and 0.726. Okay, so we're 95% confident that the proportion of Instagram users is basically between 59.5% and 72.5%. Okay, so if we take a sample of 200 people and 132 of them happen to be women, then we're confident that we have between basically, 59.5, 60, around 60% and around 72, 73% are women. Okay, or that's what we have. So what would happen if we made a 99% confidence interval? This is a very good question. What would change as we make our confidence interval formula? Yeah, we use 2.58 rather than 1.96, okay? So let me just copy everything here. We'll save that, and then we'll paste everything here, okay? All right, so if, let's say, I decide to make a 99% confidence interval, okay? So the only thing here changing is now I'm doing 99% confidence, okay? So what happens now? Z is not 1.96. Z is going to be 2.58. Does anything else change? P hat is still 0.66. N is still 200. Okay? So this standard error part, 0.66 times 1 minus 0.66 over 200, does that change at all? No. This is exactly the same. So we still have 0.033496 right there. Okay? But what changes? We no longer use 1.96. Okay? So that's going to change. Okay? And then so these numbers are all going to change also. Okay? So I'm not going to have my confidence interval from here to here anymore. Okay, and I'm not 99, I'm 95, I'm 99%. Okay, so let's do this, okay? I'm going to put 2.58 here, and that changes this to 2.58, okay? And so I come over here, and I'm going to do 2.58 times 0.033496, okay? And I have 0.0864. Okay, so I have 0.66 plus 0.0864, and that takes me to 0.7464. And then I do 0.66 minus 0.0864, and I get 0.5736. Okay, so my confidence interval is from 0.5736 to 0.7464. Everything else is the same, right? Okay, so I'm now 99% confident that P, the proportion of women, Instagram users who are women, is between 0.5736 and 0.7464. Okay, so we are now more confident. What changed? How does this interval compare to the other interval? It's wider, right? Okay, my margin of error is now, before I had give or take 0.066, okay? Give or take 0.066. And now it's give or take 0.0864, okay? And so the trade-off is if you want to be more confident about your interval containing the true value of P, you've got to make it wider, okay? So think of it this way, okay? Let's say there's a bad guy, a criminal on the run, okay? And he's running from the cops, and he happens to get out, and he's hiding in the neighborhood, okay? And so the cops want him. They're going to do a hunt. They're going to search for the guy, okay? So they partition. They draw basically a line around a block, and they say nobody's allowed to go in or out until we check everywhere and make sure we find this guy, okay? Now, if they want to be absolutely confident that the fugitive, the criminal, is within the search zone, what would they do? They make a giant search zone, okay? But what a giant search zone is a lot of work, okay? Or it's not very helpful, okay? Just say, oh, we want to make sure that we find the criminal. Okay, well, let's make Los Angeles County the search zone, and we'll check every nook and cranny in Los Angeles County to find this guy. Well, if they had the manpower to do that, then I'm pretty sure that the guy's somewhere in LA County or whatever, okay? But that's obviously too much, so they can reduce their confidence. They could say, well, let's just search this section of the neighborhood, okay? They're trading off their confidence. Maybe the guy isn't within this little section of the neighborhood, and so they might miss finding the criminal. But there's a balance there, right? Same thing here. You can be extremely confident, but you're going to have a very wide interval, which might not be helpful. I can always say I'm 100% confident that the percentage of women Instagram users is between 0 and 100%. I'm 100% confident that the proportion of people who, have smoked marijuana is between 0 and 100%. Okay, I can be 100% confident about everything if I say it's between 0 and 100%, but that's not useful. It's not helpful to say that. Okay, so we can say, well, I'm 99% or 95% or whatever. We're trading off confidence for creating a smaller interval. Okay, and again, it's a statement of confidence, meaning, is it possible? Here we made a 99% confidence interval. Is it possible that the percentage of Instagram users is actually 56% outside of this interval? Because my interval goes from, basically it says it's between 57 and 75%. Okay? It's possible that the real percentage in the population is outside of this interval and that my interval is actually wrong. Okay? But the only way for that to happen is that when I took my random sample of 200 people, I just happened to get a freak sample that had far too many women or far too few women, okay? Because of random sampling, we might get a freak sample that's really weird that throws us in the wrong direction. But we're hoping that that's not the case, and that's why we can assign confidence levels or confidence percentages to our confidence interval. Okay, I hope that explains everything. We'll see you guys next week. Yes, there are examples to this.